Kubernetes on Oracle Cloud can be deployed in one of the three ways. You can install as you do in on-premise using tools like kubeadm, or you can use automation software like Terraform. And the third and the most common, which is managed Kubernetes, called Container as a Service. In Oracle Cloud Word, also called as Container Engine for Kubernetes. And when you deploy Kubernetes on Oracle Cloud in a managed cloud manner, the registry to store images and the master node of Kubernetes Engine is managed by Oracle, whereas you as a customer will manage all the worker nodes. And depending on the region in which you're deploying your Oracle Kubernetes, you can deploy the worker node across availability domain, or if it's a single availability domain region, you can deploy the worker node across fault domain. We're going to cover all this and things like networking in Oracle Kubernetes, including how to configure load balancers for OKE or underlying storage for persistent volume, like the file storage service or block volume. We're going to cover all this in today's episode on Oracle Kubernetes for beginners. Welcome to another episode of weekly video series on Kubernetes with me, Atul Kumar from team K21Academy, where we take you on the journey from complete beginner in Kubernetes to a certified Kubernetes expert in Kubernetes and cloud native applications. Now, before I tell you about Oracle Kubernetes for beginners, let me give you some context behind this. Kubernetes is an open source container management software and it's managed by Cloud Native Computing Foundation, CNCF. And they have two certifications for Kubernetes. One is Certified Kubernetes Administrator and second is Certified Kubernetes Application Developer. And we have a training for both of these. One is Certified Kubernetes Administrator and we also run some free classes about these certifications. So this one, Kubernetes Application Developer, and how you can get hold of these free trainings, I'll tell you towards end. So in these free trainings and the paid program, we get a lot of students from Oracle background who are working on Oracle Cloud, and they wanted to know more about how to deploy Kubernetes on Oracle. So we decided to add a additional bonus in the program, talking everything about Oracle Kubernetes. And I thought it will be useful for you to see or at least get an overview about Kubernetes on Oracle Cloud. So let's first begin with what is Kubernetes or containers and why it became so famous in last 4 or 5 years. Now, if you already know these things, you can skip a couple of minutes and head on straight to the point where we go on to the Oracle Kubernetes. So if you look at development and deployment processes, the development process changed from waterfall model to agile, and now we are living in a world of DevOps. Similarly, the application architecture has gone from monolithic, where everything bundled into one single application, to then came N tier, where you have database tier, apps tier, and web tier. And nowadays, that monolithic application is broken down into microservices. So each functionality is a microservice running on its own container, and hence the deployment and packaging is moved from physical server to virtual server and now in containers. And if you have one or two or three containers, then it's fine. And when you have hundreds or thousands of containers, then managing these containers become very difficult or challenging. And hence you need a container orchestration tool like Kubernetes. So these containers or Kubernetes can run in on-premise in data centers, on a bare metal or on virtual machines, but they can also run on cloud. Now you might say, hey, we were already running these applications on a virtual machine, so why we need containers or Docker? Or what is the difference between virtual machine or Docker, and what is the challenge that containers solve? So if you look at very quick, high level, each virtual machine has its own guest operating system. So if you deploy these microservices on their own guest operating system or on their own virtual machines, the application becomes very bulky. The time it takes to start these applications with a virtual machine is quite long. It takes few minutes to start these virtual machines. Moreover, these virtual machines are big and bulky and they're resource intensive, whereas containers are lightweight and they take just few seconds and very less resources on compared to the virtual machine. Or if you want to understand the difference between containers, and Docker is one of the type of containers, then have a look at the previous episode I did, which is k21academy.com/Docker12. We discuss why the containers or Docker are preferred over virtual machine for microservices. So if you're not familiar, then check it out to k21academy.com/Docker12. Now, at the start, I mentioned that in Oracle Kubernetes or managed Kubernetes on Oracle Cloud, the OCI registry is absolutely free and managed by Oracle. So let's look at what is registry or Oracle Container Registry or Docker containers. So in order to understand the registry, we need to first understand the Docker architecture. On a very high level, word Docker and containers are used interchangeably. And Docker is one of the type of containers. So install Docker software or container software on a host that is called as the Docker host. And the background process which continuously look for the request or serve or create container and manage containers is called as Docker daemon. And you have a client, which could be the Docker host itself or external client. This is where you issue commands to create the containers. Now, containers are created using something called images, and these images are stored in a registry. And typical example for registry from Docker is Docker Hub. So when you need to create a container, you're going to pull the image from the image registry, bring it to the local host, and then from these images you start containers. And from the same image you can run one or more containers. So there'll be an image to run containers that are related to Nginx web server. And you can have another image for Redis, which is a caching software, and you can start multiple containers from this software. And these images are created from a component called Docker file. So using your Docker file, you build the images, and these images are used to create containers. Now, if you want to know more about this in detail, I've covered this in one of the previous episodes at k21academy.com/Docker13. So these images on the Docker repository are stored in Docker registry called Docker Hub. So this is an example of all the different type of images which are stored on Docker repository. And the similar implementation or the implementation of a container registry or Docker registry on Oracle's cloud is called as Oracle Container Registry or OCI Container Registry. And how to create this container registry on Oracle Cloud? Let me take you to Oracle Cloud Portal. So we are right now in Oracle Cloud, and go to hamburger menu on left hand side here. Scroll down and look for this developer service, and under here click on container registry. And from here you can click on create repository, and this is how you can go and create repository. That repository can be private or public. So I've already created this repository here, and in this repository you can create your own images or configure Kubernetes to pull the images from this repository or registry so that containers can be started. So that's OCI Container Registry. Now, before we move forward and look at Oracle Kubernetes Engine, let's first understand why do you even need Kubernetes. So if you see in the diagram, there are multiple hosts, and on each host you can run multiple containers. And typically you run 15, 20 containers depending on the type of application and spec of the machines. You can run multiple containers on the same host. Now, if you have one host or just a handful of containers, then you can manage these containers yourself. But if you have hundreds and thousands of containers, which is quite common in a medium to big size implementation, that's when you need some container orchestration tool like Mesos or Kubernetes or Docker Swarm. And in last few years, Kubernetes has come down as a complete winner for container orchestration and a management tool. So in Kubernetes, you have a master node and you have a worker node, where master node works as a management layer and your applications run on the worker nodes. And on these worker nodes, you run a component called pods, which is nothing but collection of one or more containers on which your application runs. So the Kubernetes will create one or more pods on a worker node, and the application will be running on these pods. And all these pods, applications, worker node, all these are managed by the Kubernetes master node. And this master node is free on Oracle Kubernetes and also managed by Oracle, where you as a customer will be managing all these worker nodes, and you'll be charged only for whatever the resource uses for these worker nodes. So that's a compute, and the underlying storage you only pay for those worker nodes. So just to recap, what you get in Oracle Kubernetes, you get a Kubernetes registry to store all the images that's managed by Oracle and absolutely free for you. You only pay for the underlying storage in for registry. Similarly, the master node is fully managed by Oracle and you don't pay anything for the master node. Now, master node, there are three copies of the master node, and if you're in a region which has three availability domain, then your master node will be deployed on three availability domains within a region. Or if you are in a region that has only one availability domain, then there's a concept of fault domain, and your master node will be deployed on these three fault domains. And while deploying the Kubernetes cluster on Oracle Cloud, you can decide how many worker nodes you want and then later add or remove these worker nodes from the OCI console. And if you're a beginner in Kubernetes, you can look at the architecture of the Kubernetes that consists of the worker nodes or multiple worker nodes and a master node. And in this master node, you have the API server, controller manager, scheduler, etcd, and then different processes and worker nodes like kubelet, cadvisor, kubeproxy, and a common network interface so that the worker nodes can talk to each other, and how this communication happens and what are the uses of these different components within Kubernetes architecture. I've covered this architecture in one of the previous episodes, which is available at K21Academy.com/Kubernetes 12. We'll also look at the uses of all these components. Now, if you're deploying Kubernetes on cloud, there is an additional component that you get apart from these master node and worker node, and that component is called as cloud controller. Now, the role of cloud controller is to get all the necessary infrastructure for your Kubernetes cluster. So things like the virtual machines for your worker node or the underlying storage, it could be a block storage or it could be a shared file storage service or load balancers. All these resources are being managed by the Kubernetes master node through Cloud Controller Manager. Now, if you want to know more about the architecture, as I said, look at k21academy.com/Kubernetes 12. That will also cover the various component of Kubernetes. And then if you want to understand a little bit more about difference between containers and Kubernetes or Docker versus Kubernetes, then you can look at k21academy.com/Kubernetes 16. Now, there are three other things you should be familiar when you're deploying Kubernetes on Oracle Cloud. One is networking, including deploying load balancers. Second is storage and including storage volume. And third is security, which is how to protect these Kubernetes resources. And in order to understand these three things, you need to understand the basic concept about pod. So as mentioned earlier, the pod is the smallest deployment unit that you deploy on a worker node, and pod can have one or more containers. Typically or ideally, you want to have one container per pod, but in certain scenarios, you might have to deploy two or more containers within a pod. And you deploy these pods on the Kubernetes cluster or Oracle Kubernetes using something called YAML file. And this is a representation of that YAML file, which is saying I'm deploying a pod and name of that pod is static web. It's running a container with the image Nginx and listening on port number 80. So when you're deploying these pods on and running application on these pods, you need to understand how can a client talk to these applications running on these pods. Now, each pod gets a dedicated IP, and ideally you can run or connect to this IP and access the application. But then pods die, new pods come up, you add new pods in the cluster, and as and when pods come and go, the IP addresses keeps changing. And that brings networking challenge for clients to connect to these applications via the pod IP. So if you are a client, you would never connect directly to pods on the pod IP. And instead of that, you configure something called service. And now this service is different from microservice. This service is the way for client to connect to the application running on pods. And so service gets a dedicated IP which remains static from client point of view. And on that service, you define something called label. And so in this case, I'm saying on left hand side, I'm saying my service is represented by two labels where environment is equal to prod and version is equal to v1. And then when I'm defining the pod, I'll give each pod sub labels. And when the label defined on the pod matches with the label defined on the service, then service knows that I need to forward a request to these respective pods. So in this case, service knows that there are three pods with these labels. So I'm going to forward a request to all these three pods. Now, if this port, one of the pod goes down or can started with a new IP address, the service will still forward to this new IP address or a pod with a new IP address because that has the correct label. Now on the right hand side, if you see, there's only two pods are matching with these labels. So service will forward a request to these labels. So you should be familiar with networking in Kubernetes. And in order for you to support this connectivity, your Kubernetes support four different type of services. One is cluster IP, second is node port, third is a load balancer, and fourth is external names. And when you're creating the service, you define what kind of a service is this. So this is another YAML where I'm defining a service and I'm saying the name of the service is my service, type is node port, and it's basically selecting a pod with a label called app as my app, and it's listening on port number 80, and target port is 80 and the node port is 3007. And like that, I can define the load balancer type of cluster as well. So in Oracle Kubernetes, you will typically run multiple pods with the same application and you'll be deploying the load balancer in front of that. And in Oracle, you can have these load balancers as public or private. So if your traffic is coming for these applications internally and it stays always internally, then you keep the load balancers public. But if you want to expose these load balancers to the internet, then you can make these load balancers public. And if you want to know more about the load balancers in OCI, you can look at one of the previous episodes on load balancers in Oracle Cloud by going to k21academy.com/OCI 64. So this is an example of a load balancer in Oracle Kubernetes where I'm saying my type is service and the service type is of load balancers, which is listening on port number 80. And behind this service, I have a pods which has label called app is equal to Nginx. So my end user will connect to the load balancer and then I'll be having a load balancer with a service defined of type load balancer forwarding request to multiple pods with the label app is equal to Nginx. And if you want to see the status of the services, you can run a command called kubectl and space and get space all. That will tell me the status of all my pods running, including the service. So this is here one of the service which is defined with a load balancer where my external IP of this load balancer is 192.0.0.2.22. Now, apart from this networking concept, there's also something called Ingress controller on Kubernetes, which is an application tier level load balancing on layer 7 of your OSI networking model. So you define controllers like Nginx Ingress controller or F5's Big IP Container Ingress controller, so that with one controller you can forward request to the different pods based on the rule you define. So for example, you have a one URL and you can say if anyone want store in that URL /store, forward it to these particular set of pods. Or you have, for example, /reviews, forward it to different set of pods. So these can be handled by the ingress controller of type like Nginx or F5's Big IP Container Ingress and a few more as well. Now, if you want to know how to set up these ingress controller, you can look at in Oracle Cloud documentation that gives you some examples of setting up these ingress controller. Now, I'm going to add these links in the reference notes on the blog of this episode, which is k21academy.com/Kubernetes22. The next is storage in Kubernetes. And there are a lot of applications that are deployed on Kubernetes and need the persistent store. And this is where the storage volume comes in handy. So you have a Kubernetes cluster and you as an administrator will go and provision something called as volumes, which is nothing but a storage of different sizes. So whatever size you need, you carve out that particular volume. We call it as a persistent volume. And then Kubernetes administrator or the developer will claim that particular volume and say, I want maybe 1 gig chunk of that volume. So that's called as persistent volume claim. And that claim then can be used in your application running on a pod in the Kubernetes cluster. So the cluster administrator will provision these volumes, and then your developers will be binding these claims on of the storage volume through the persistent volume claim, and the pods will be these using these volumes through the persistent volume claim. Now in Oracle Cloud Infrastructure, there are three different type of storage options available: file storage, block storage, and object storage. And out of these, in your Oracle Kubernetes, you can use file storage, which is a shared file system, or a block storage, which can be used with a one host at a given point in time. Now, if you want to know more about the storage options in Oracle Cloud, you can have a look at one of the previous episodes by going to K21Academy.com/OCI 16. Now, depending on the requirement, you probably might be using either a file storage service or you might be using a block storage service. Now, a file storage service is a NFS3 compliant storage that can be mounted across different machines or different hosts. So as you see in the diagram, you have the multiple nodes or machines on which you're deployed acting as a worker node, and on each of these worker nodes, you have multiple pods running. And these pods, when they need the storage, you can have a file storage service running on a particular mount on an IP address, and then that file storage service can be mounted on these different host or worker nodes. And then using the persistent volume claims, your pods can then use this storage service, and that can be shared across different pods. So the flow is your cluster admin set up this NFS and then creates a persistent volume. And then your developers, users, or the Kubernetes administrator or Kubernetes developer will use these persistent volume claims in the pods. Now, if you want to define these file storage service, assuming you've already configured file storage service and presented to the node, then you define a kind of storage class that signifies where is the OCID or Oracle Cloud identifier for that mount target where this file storage service is mounted. And then you're going to create a persistent volume. This is one of the YAML file to signify that it's a persistent volume. Storage class is the one which you've created earlier of type storage class. And then the server IP here represents the IP address of your file storage service, which is NFS file system. And then on path through which you are configuring this file storage service. And then finally, you take a persistent volume claim so that your pod can use this persistent volume claim, where the storage class name will match with whatever you have created earlier, which is OCI-FSS here through this YAML file here. Now that's one type of requirement where the multiple pods running on different hosts need to access a file system or underlying storage. Or the another service which I mentioned earlier was block volume. And in this case, the block volume is usually tied to one particular virtual machine configured within an availability domain. So here you'll be defining a persistent volume claim, and this time you're giving the storage class name of storage class which you've already defined, which is OCI-BV, which is block volume. And the next topic is about security in Kubernetes or Oracle Kubernetes Engine. And in order to understand security, you need to understand the actors that are part of security. So you will be having who is accessing your Kubernetes resources and what resources they are accessing. So in who, you have users who are hitting the Kubernetes cluster using tool like kubectl, and you can have a group of users that you can put them into a group so that you can apply the appropriate roles. Then you have a service accounts, which will then go on behalf of the Kubernetes cluster and access resources. So for example, you have worker node talking to the Kubernetes cluster or other service accounts. And then there are some resources like pods. There might be resources like the deployments or persistent volume and so on. So these resources will be granted access or revoked access via the role. So some resources will have access to a role, and depending on, you can define privileges like read only or read update and so on. And these roles will give an access or remove the access based from the resource. And through the role binding, these will be given to a user, group, or service accounts. So this is the feature that comes by default with Kubernetes. And you can then integrate these accounts with identity and access management within OCI. So in OCI, there is a concept of policies and compartments. That is to give who can access what kind of functionality within the Kubernetes cluster in Oracle Cloud through the OCI console or through the APIs. And similarly, you have groups and users which are tied to Identity Cloud Service, which is another user management in Oracle Cloud. That group of users can be integrated with the roles or groups in your Kubernetes cluster. If you want to understand more about identity and access management in Oracle Cloud, you can look at one of the previous episodes by going to K21Academy.com/OCI 13. Then apart from these users and groups, there's also a concept of secrets in the Kubernetes cluster, and the secrets store, as the name suggests, the sensitive information like passwords. And these passwords are stored in the component called etcd, which is also the configuration management for Kubernetes that stores all the configuration related to Kubernetes cluster. And etcd is a distributed database. So these passwords for this sensitive information in secrets are stored in etcd. So when you create a Kubernetes cluster, the data on etcd or any data for master node and worker node is encrypted by default data at rest level. Now these data at rest, you can by default it's encrypted using keys from Oracle, but you can create your own keys and then encrypt this data using your own key for the data stored in etcd for these secrets. Now apart from that, you also have the network policy. So by default, all the pods can talk to each other freely. So an application running on pod 1 can talk to application running on pod 2. Now, in typical enterprise application, you have pods for the database tier, you have pods for application tier and different web tier. So you don't want your web tier to talk to, or the application running on web tier like Nginx server talking directly to the database tier. You may want to go through it through the apps tier. And this is where you configure something called network policy, which protect and say what application or what pod can talk to what pod. So in this example here, we are defining a network policy which says that my pods, this policy is applicable on a pod with a label called HoloDB, and the connection or the policy type is ingress, and it's allowed only from where my pod label is Holo app. So we are restricting saying that the connection is allowed onto this pod only from the application running in this pod, and on only the port number 3306 is allowed. While if any other pod try to connect with a different app, it is not allowed to access the database pod or application running on the database server. So that's a network policy. Now, by default, as of today, I'm recording this in August 2020, the network policies are not by default defined in Oracle Kubernetes. And if you want that network policy to be implemented in Oracle Kubernetes, you need to deploy Calico, which is another network deployment. So you define the Calico, and then you define a network policy where labels are, we are applying this and saying a role is equal to DB. So any pod with a role DB, we are defining two policies, ingress and egress. And in ingress, we are saying allow from this block of CIDR IP addresses. So any pod within this CIDR is allowed. And for egress, which means going out, any pod from this going out is allowed. Similarly, if you want to define saying that every connection from outside this pod is denied, you can define a YAML file like this. Or allow all the ingress, which means allow all connections, you can define a network policy for that as well. So the network policy is to control access to the pod, both incoming and outgoing. And if you want to know or look at how to install this Calico and set up network policies on Oracle Kubernetes, on the show notes on the blog, I'll add these links so you can refer them. And if you're watching this outside our blog, then you can look at all the show notes by going to K21Academy.com/Kubernetes 23. I'm going to add all the details and related notes which I've discussed so far in this blog. So have a look at K21Academy.com/Kubernetes 23. So just to do a quick recap, you have Kubernetes, which is deployed on Oracle Cloud as a managed Kubernetes, where the master node is managed by Oracle, whereas you as a customer manage the worker node. You get master node absolutely free, but you only pay for the worker nodes and especially the compute and underlying storage. The OCIR, which is a Oracle Cloud Infrastructure Container Registry, that container registry gets absolutely free and managed by Oracle as well. Now this master node can be configured or highly available or 3 copies of master node on 3 availability domains in a region. If a region only has 1 availability domain, all the 3 master node will be deployed on separate fault domains. Now the worker nodes can be run across availability domain or fault domain, but within a region. If you want to know more about what is the difference between a region, availability domain, or fault domain, you can check it out at K21Academy.com/OCI27. The region is geographical location. Inside that, you have up to 3 data centers, usually 1 or 3 data centers. And within each data center, which is availability domain, you have 3 fault domain. So more on this in one of the previous episodes. Then pods are smallest deployment unit on which you deploy your applications. And when you need to talk to a application running on a pod, instead of directly connecting to the pod IP, you define a service and you connect via the service. Service is mapped to a pod or application running on a pod via the label. And within service, and there are different type of services that are available on Kubernetes. And if you're running your application in HA on multiple pods, which in a production environment you should be, then you define a service of type load balancer via a YAML file. Now, one tip here is that though you'll be able to see that load balancer on Oracle Cloud Infrastructure, don't change anything via the OCI console. Always use Kubernetes to modify or update these load balancers or services in load balancer. And you can do it via the YAML file. Now, apart from that, there's also Ingress controller, which is a layer 7 HTTP or HTTPS level load balancer to distribute traffic based on the rules you define on the URL. And there are Nginx Ingress controller or F5 Big IP Container Ingress controller or other types as well supported on Oracle Kubernetes. For storage, there's a concept of persistent volume and persistent volume that you can use to get the data or store the persistent data on a storage volume outside the container so that you store the data stays after the even life cycle of the pod or application running on the pod. And this persistent volume can be a file storage, which is NFS compliant shared file system, or a block storage. Again, you define these storage using YAML file. First, you define storage class, then you define a persistent volume, and then you define a persistent volume claim and use these claims in the Kubernetes pods. And the previous was about security, controlling the access of your Kubernetes resources via the role, and these roles are binded to a user or a group or service account. Also storing the passwords in a secret store called secret, which is stored in etcd, and also defining the network policies to protect what all applications can talk to the pods or what pod can talk to which pod, both ingress and egress. Now, if you're to go deep into, I think if you're working on Oracle Kubernetes, I highly recommend you to understand Kubernetes in depth. And the best way to learn is by going through a Kubernetes certification. Now, this is a hands-on lab type certification. It's not a typical your multiple choice. You actually have to do the labs. And there are 2 certifications as of August, which is Certified Kubernetes Administrator and Certified Kubernetes Application Developer. Administrator, as name suggests, is targeted for admins and architects, whereas developer is targeted for developers as well as testers and also for enterprise architects. Now, there's a 3rd certification coming in November, which is for security professionals. We'll talk about that later in one of the future episodes. Now, I run a training program with Kubernetes experts where we bring Kubernetes expert and cover a step-by-step comprehensive training program, which is one for developers, which is Certified Kubernetes Application Developer. And apart from the practical part and hands-on labs, we also provide 1-year on-job support and prepare for the exam. And if you want to know what all exam topics you should be preparing and what all hands-on lab you should be doing both for Docker and Kubernetes, which are 35 labs, or if you want to attend a free class covering Certified Kubernetes Application Developer, everything related to that you must know about this certification, then I would like to invite you for a free class that I run with Kubernetes expert, where we'll cover things like why you must learn Docker and Kubernetes. We'll go slightly deep into monolithic versus microservices or VM versus containers or why Kubernetes. And the most important is 7 things you must learn in order to not only get an in-depth knowledge about the Kubernetes application development role, but also the 35 labs you must do. So if you're a developer or a tester or an enterprise architect, then register for this free approximately 90-minute class by going to K21Academy.com/Kubernetes Dev 02. Or if you're an administrator or an architect and who'd like to know how to install and configure and manage these networking, storage, Kubernetes cluster, and so on, there's another certification which is Certified Kubernetes Administrator, which is CKA. Again, this is also a hands-on lab training program. It's a step-by-step comprehensive training program with exam preparation and 1 year on job support. Again, what all topics you should be learning in this certification, and the 33 hands-on lab we recommend you to do, including horizontal pod auto scaling, things like troubleshooting or auto scaling or deploying a persistent type of application, and a lot more. If you want to know more about this, then another free training, but this time for targeted for administrators. So if you're an administrator or a beginner in Kubernetes, or already working on Kubernetes or Docker, but would like to now become certified, because when you certify, that's when you open up for a lot more opportunities. So free class at K21Academy.com/Kubernetes02 for targeted for administrators and beginners. Now, next week, I'm going to take this, what we have learned today, to the next level by provisioning a Kubernetes cluster on Oracle Cloud. We will connect to the Oracle Cloud Console and go to this Kubernetes cluster and look at some of the things that you need to select and what each of these means, like compartment. And when you create cluster, the different options you get in order to create the cluster. And once you've created cluster, how do you connect and access this cluster? So I'll see you next week on how to provision a Kubernetes cluster on Oracle Cloud. Until then, if you like today's session, then don't forget to share it with your colleagues who are working on Oracle or Oracle Cloud Infrastructure, or anyone who is working with Kubernetes. I'll see you next week.